So just an overview of the things that we've covered in the course. Of course, there's a little bit of the background about myself, how it is that I developed my interests, developed this knowledge, and kind of the discoveries I made along the way. And going through then into critter identification under the microscope, using a microscope. We had gone through what all of the different organism groups look like. What do bacteria look like, all their kinds of shapes and sizes, and how you differentiate the good guys from the bad guys. Really easy to pick out the spirilla, to pick out the C-shaped bacteria, to pick out the spirochetes, which are things that are notably simple to differentiate from the other bacteria. And, of course, those bad guy bacteria, the spirilla, the C-shaped vibrios, and the spirillums, the spirochetes as well. Easy to tell that you've got some really bad organisms. Not so easy when we're just looking at cocci and rods and some of the different sizes and shapes there. As we're looking at fungi, diameter of the fungi, whether they've got septa, whether they're dark-colored or clear, things that we differentiate the good guys from the bad guys. And, of course, realizing that no simple classification like that is 100% perfect, but in general we can make these differentiations between beneficial and not-so-wonderful organisms. Then looking at the beneficial protozoa, the flagellates, the amoebae, what do they look like, being able to tell those from the ciliates. Ciliates having cilia over most, if not all, of the body, moving fairly fast and rapidly, versus the flagellates that tend to bumble, and then the amoebae that ooze. So, again, pretty easy to tell the differences between the bad and the good. When we move on to nematodes, looking at mouth parts, and, of course, the bad guy nematodes have spears in their mouths with nodules, knobs on the end of that spear. So being able to identify these different organisms and start to figure out right off the bat whether you've got beneficial organisms or whether you're dealing really with the not-so-wonderful. Understanding the habitat, then, that differentiates between what's more likely to be good versus something that is not good. Those organisms that live in reduced oxygen conditions tend to be the disease causers, tend to be the things that attack, are harmful to our plants, the anaerobic organisms that convert our soluble inorganic nutrients into gas forms so that we lose our nitrogen, we lose the phosphorus, we lose our sulfur. They're lost as gases, and so, of course, you're now not going to be able to grow your plant material. Also looking at when we're dealing with anaerobic conditions, we're making some really nasty organic acids with very low pHs, and we discussed some of the really typical smells of these really bad organic acids, so quite easy to tell when things have gone bad in the soil and you're setting the stage for the diseases to be able to rule over the beneficial organisms. And, of course, then alcohol is only produced under anaerobic conditions, and alcohol is going to immediately solubilize your root systems, formaldehyde, some of the terpenes, some of the phenols. So getting across the idea that anaerobic is a very bad idea. We don't want to have any anaerobic conditions in our soils. We don't want our compost to be anaerobic. We don't want our teas to be anaerobic because we don't want to lose our mineral nutrients, our soluble inorganic nutrients, and we don't want to be making toxic materials. We don't want to be dropping the pH extremely low. So even though some people may be out there saying there's nothing wrong with anaerobic, if they're trying to kill things, okay, but then that's a pesticide approach. That is not the attitude that we want to be developing when we're working with nature. We want to develop the habitat that's going to promote the beneficial organisms, and that means aerobic. So we want to build structure. We want to make certain that we have those organisms that are going to promote our plant growth and not harm our plant growth. So understanding soils, we're trying to fix the problem. We don't want to be masking symptoms. A Band-Aid approach is not appropriate. We want to make certain that we're solving the problem and we're making the system sustainable. So moving along then. Module 2, this good soil has good critters. What is the proper biology to grow in our plants? And we have to start understanding succession, that very early in succession, after your soil, after your ecosystem has been severely disturbed, and we're back to a condition of strictly bacterial. And then Mother Nature starts to improve the biology in your soil, so you build structure, you get the air and the water infiltrating into the soil, roots can grow deeper, and so we're now going to select for better plants. We're going to be moving from the weeds into our brassicas, into the riparian or wetland plants, some of the earliest successional grasses that aren't so wonderful, but we're moving in the right direction. As we continue to build the fungal component, we start building better protozoa, nematodes, start increasing diversity in our soils. We're going to be moving on to the later and later successional systems. So we need to understand that Mother Nature pushes succession from those very early, not very productive systems to more and more and more productive. We're going to the moving on into our vegetables. We're moving into our row crops. We're moving into shrubs, and then into deciduous forests, and then conifer or old-growth forests. That typical successional process is pushed by ever increasing the fungal component in the soil. And so when we're trying to think about how do we make the soil most appropriate for growing the plant that we want to grow, we have to understand that successional system and figure out, what plant do I want to grow and what's the appropriate balance of bacteria and fungi, protozoa and nematodes, so that we set the soil to grow that particular plant species. And so once we get that figured out, now how are we actually going to put that biology back into the soil? And that's where we get into understanding compost and compost tea. What's the biology in your compost? If we want to get more fungal, if we want to get more bacterial, if we need more protozoa, if we need more nematodes, what is it that we do specifically when we're making our compost and making our compost teas or our compost extracts? The results of then getting the proper organisms means that the plant we want to grow is going to do the best. And so setting the stage to get the production that we want. And then, of course, going into a soil food web program, we have to look at what is in the soil. So when we're asking you to put together a program, we're asking that you look at your soil. So you've got your microscopes, look at your soil, figure out what the biology is in your soil right now, and then you can typically determine what's missing. The reason I've got weeds is because I don't have the fungal component, I don't have the protozoa, I don't have the nematodes, and so now how am I going to get those organisms back into the soil? We're going to figure out what kind of compost do you need to make. So do you need more fungal foods? How are you going to get the protozoa in there? And so we want you to think about what you would do specifically to bring along the organism groups that are lacking. You have a number of choices when we're putting in compost. Do you spread it on the surface? Is that going to be the most effective way to get the organisms into the soil? Do you need to perhaps till it in? Because as you till that compost in, you're breaking up compaction layers, you're putting the organisms deeper into the soil, and then hopefully they'll be able to grow and start to build structure immediately. If that doesn't work, what do you think about next? What's the compost teas or compost extracts? So plan things out that you're going to be testing your soil. After you add that compost back into the soil, you're going to test when in order to determine whether that compost addition is doing the job that you want it to do. If it is going along just perfectly, then You don't have to do anything more. You just keep monitoring. If it didn't work, then what's the next step to try? If your compost isn't good enough, the organisms aren't coming along, you want to think about some of those aspects and put that into your program. What is the biology? What's your goal? What are you trying to reach for the plant that you're trying to grow in the system? Moving on to Module 3, fixing poor soil. So, how far down do roots go? How do you fix compacted soil? It's getting that biology into the soil. How are you going to do that? Understanding species diversity. How do you improve species diversity in a compost pile? So we went through all of those things, lots of specific information on how to fix those problems. You want to understand that you've got to get the biology into the system and then maintain it. How does it continue to maintain that balance? You've got to be thinking about residues going into the soil, or is just the exudates coming from the root system going to be adequate for maintaining that biology in your soil? Do you have to constantly be putting compost back into the system? So think through how you're harvesting your plants. What are you doing with the residues? Maybe you actually want to be thinking about understory, plant species that don't grow very tall but maintain a layer of vegetation at the surface so you don't get compaction from rainfall. You're maintaining the exudates coming out of those root systems. When you plant into that understory set of plants, how are you going to knock back the competition that your desired plant, your row crop, your transplant plants, how are you going to make sure that they get established, they get connected into the below ground system as rapidly as possible? So going through some of those considerations. Then we got really specific about the different kinds of compost and how do you make thermal compost, some of the recipes, worm compost, how do you keep a worm compost aerobic, how do you keep the worms happy, how often do you have to feed them, and what do you feed them? Really understanding that compost is both a fertilizer as well as an inoculum of the organisms, being a little bit careful about, we don't really want to be out there claiming that compost is a fertilizer, because then we walk into a whole lot of trouble with some of the definitions that people have with respect to a fertilizer is only something that is an inorganic, soluble nutrient. And, of course, compost is anything but inorganic. Lots of not soluble, lots of organic materials, but with the proper biology, we cycle those nutrients into a plant-available form. So compost is indeed a fertilizer, as well as an inoculum of the organisms. And then how do you control the kinds of organisms that would be present in your compost? And then again, we came back and touched on that aerobic, anaerobic comparison. Using microscopes, what are the organisms? How do you know that your compost is really good? There are a number of indicator things that you can look for. You can, the smell of the compost is a good indicator of whether it's good or if it's bad. The black color versus brown color. Looking for the actinobacteria. Any of those things would lead you to managing the pile in a different fashion. Then we're going on to compost tea, where we're talking about, analyzing your compost to make sure you have the organisms. And now you're going to extract those organisms into the water, and you may choose to apply it as an extract, especially if you're going into soil. Getting those organisms into the soil, you don't really have to have them activated. You don't have to have them growing, living, if you're putting it into your soil. But if you're going to be putting these organisms onto the leaf surfaces, you really need to make a compost tea, which means you're adding foods into that extract in order to wake those organisms up, get them growing, produce the glue layers so that they will stick to your plant surfaces. How do you know that your organisms are present in your tea? How do you know if they're growing? So again, microscope work. So that's a brief summary of the course, I think. Did I cover everything, Helen?
Yes, I think you did, and I think it's a very, very good reminder. So, Elaine, I'm not quite sure how to close this except to say thank you very, very much. I love your work, and we're very excited to be part of the Soil Learning Centre bringing this course to folks. Is there anything you'd like to say on closing?
I'd like to thank you very much for putting in the time and the effort to give this information, put it out, make it available to people, and it's only because of you and the time that you've put to put it all together and offer it to people. I don't have the time. I don't have the staff to manage to do it myself, so it's absolutely fantastic. Thank you very much, Helen, for putting this time and effort into it, and I hope that those people who didn't get their questions answered, or maybe I answered part of the question that you wanted to know about, that you'll go ahead and sign up for the course. So more of this information, of course, lots more hours going over these kinds of things where I try to be slower, explain it all in very clear information. So I hope a lot of people will sign up for the course so they will get their questions answered.
Elaine, I'm sure they will, and thank you on behalf of everyone on the line that you've been here talking to us today. And I'm going to say goodbye. And for those of you who are there, please stay online. There's a button on the left of your screen that you can click to look at what Elaine is offering in her course. But in the meantime, Elaine, thank you.
Okay.
And we'll move on with looking at what the course is offering.
Yep, and I hope we can do this again. Of course, with the course comes a couple more opportunities to have this kind of interaction.
Yes, and people online, please put your comments in now. You've got room to leave questions, but we've got some lovely comments coming through. Thanking you, Elaine, for your fantastic information. I can't believe they're getting this from you so readily. So please leave your comments, and please leave your comments what you'd like to hear next from Elaine. We may be able to arrange another one with you.
Yep.
So that would be an extra bonus for us.
Okay.
So thank you.
Thank you, and hope we will continue this in the future.
We certainly will. Thanks, Elaine.
Okay.
All right.
Take care. Bye-bye.
Thank you. Bye. Just looking now, if you click on that button on the left for the registration, it opens to a form which is actually telling you what the course offers. And it's got that lovely note from Elaine about there is hope and we can return the soil to health. But finishing with, you have to get the biology right for your plant, and you will if you get the whole food web back. And that's really the bottom line of this whole course, is actually understanding that whole food web and what you do need to do to get that balance. And maybe you've got bits of it, and maybe you understand bits of it, but then you get hiccups or you do something and it doesn't work. It's probably because there are gaps in your knowledge, and you really need to get educated with and find the knowledge of the soil food web to truly bring your soil back to good working health. And you also have a guarantee. You can join the course for 30 days. If you discover it really isn't your cup of tea, you will be refunded. There'll be no questions asked, but you must do it in the first 30 days because it's very, very hard to know what a course is like till you take it up. So that is a genuine money-back guarantee, but we also expect you to genuinely participate. So we invite you to sign up today. So if you know that Elaine's going to be able to help you to bring your farm back to full health, I say jump in. It's your opportunity to return your farm to health and profits, and maybe reduce your stress and uncertainty that you're experiencing. And we can give you lots of examples of what others are achieving and provide them for you. So just email help@Soil Learning Centre to get your questions answered. And while you're here, just take a minute and calculate the cost of all the farm inputs, your fertilisers, pesticides, weedicides, drenches, water, extra feed. If they total over $997, which is what the full course will cost, and you are paying that year after year, then you need to do this course. and stop the chemical roundabout, stop the inputs and return your health to your farm and to yourself, and even stop wasting your time. So I'll leave you to it, and just remember that, as Elaine says and makes it clear in a very fun way, that you must have the correct balance of biology to have a healthy soil. So thank you very, very much for joining the call, and we'll wait to hear from you. Thank you.